Hello again. Today we are going to discuss another question on maximum area applications of derivatives. A complex familiar question. So let's have a look at the question. So we know when we talk about derivatives, so we talk about maximum area, so we need to use differentiation. So this diagram again shows a parabola with inside as a built-in trapezium. So trapezium the four corners, the it's sitting on the parabola, and so this area, shaded area, is the trapezoid area of trapezoid. So in yellow, so we need to find out what is a B, so determine what is a B, so that the area of this parabola, this trapezoid, to become a maximum. So we need to find out what is a B, so that the area of trapezoid is maximum. So we need again, so let's have a look at the condition. So we have the turning point, so which is this point, is 0 and 4. And we also have the x-intercept for the parabola is -2 and +2. So this gives us the base length. So the whole length is, so if I call, so the area at the base length, so the length base, so we might call, C, let's say. Okay, so this is the C. So C obviously is 4. So from here to there is 4. So the height is the B. So what we need to establish is first, if we decide what is the maximum area, so our goal is we want to establish the relationship between area and the B. So we need to find out the function of between A and B. B is our independent variable. All right, so let's see how we can achieve that. Now, obviously, we know the area of trapezoid is half of the top base. Top base at the moment, we don't know. So let's call it, let's say it's A. So that's the top base. So we call A plus bottom base is 4 times by the height is B. So we need to now to find out what is the A. So in order to find A, so we need to decide the point, the coordinate. If we can find the X coordinate, so obviously Y is, in this case, Y is a B, is it? So Y is the height of the trapezium. So if we find out what is the X, so that this will be negative, so this corner will be negative X and a B. So the total length, so A will be double of X. So because we need a X plus X, it's absolute value. So then ultimately we need to find out what is X. So in order to find that X, so we need to find it, because that section, that point is the intersection point between this straight line and the graph, which is parabola. So if we can solve, so this straight line we know is the function as y equal to b. So that's the first relationship. So if we need to find out what is the equation for the parabola. So the equation for the parabola we know is y equal to, let's say k, we don't know, so but we know the kx, but it has to be plus 4. Why is 4? Because 4 is the y-intercept. So we're already given. So that's why we need to find out what is k. So if we can find a k, so then we can easily find out the parabola equation. So k, well, what do we do is because we got those 2 points, so we got 2. So because x-intercept 2, 0 belongs to the y equal to kx, it's on a straight line, so we belongs to that. So therefore, we substitute to find a k. So y is 0 equal to k times by 2 to the power of 2 plus 4. So therefore, k equal to negative 1. So therefore, my parabola will be negative x plus 4. So this is the parabola. So now what we do is we join those two. This is what we call equation number 2. So we put a 1, 2 together, y equal to b, and y equal to negative x plus 4. Together, join them as a simultaneous equation. We solve, so b equal to substitution method. So therefore, the x, so we got the x is, so we move x to the other side, x squared equal to 4 minus b. So therefore, the x is positive, negative 4 minus b. Now, why is positive, negative? Because we got 2x. One is on the right-hand side, the other one's on the left-hand side. So therefore, this x, we got it. So therefore, our the length of the top base, we call a, is twice of absolute value of x. So we substitute 2 times by positive square root 4 minus b. So this is our a. So now we put it into our area formula so we can establish the relationship between area and b. So we half of a is 2, 4 minus b square root plus 4 and times by b. So this is our formula. Let's simplify a little bit. So we move that one to inside. So half times by 2 is, so we got b square root 4 minus b and plus 2b. So this is our formula. Now then we say, okay, because we want to find the maximum area, so we dy or dA in relation to b, sorry, not d, with respect to b. So differentiate a with respect to b. So the first we know is product rule. So we b, so 4 minus b plus, so b, so divided by 2, and then you'll get, so obviously this will be go down, times by negative 1, and plus 2. So 2b is 2. All right, so now we will, let's simplify it. So what do we do is, we're going to simplify to, so let's do one more step. 4 minus b plus minus, because that's negative half of, so that's a b on top, square root 4 minus b on the bottom, and plus 2. So, all right, so what I'll do is we will be, let's make a common denominator. So a dash for b equal to, common denominator is 2 square root 4 minus b. So there'll be 2 bracket 4 minus b minus b plus 4 square root of. All right, simplify further. So we expand the brackets, so it'll be 8 minus 2b minus b plus 4 square root 4 minus b. Okay, so the answer is 2 4 minus b, so the 8 minus 3b plus 4. All right, this is our derivative, but we need to, obviously we need to continue. Sorry, this to the next page. All right, we moved on to the next page. So let's say we will, in order to achieve the area is maximum, we need to let a dash equal to 0. So therefore, the top number 8 minus 3b plus 4 square root 4 minus b equal to 0. So that's leads to 4 square root 4 minus b equal to 3b minus 8. All right, so that's, so we both sides, because we want to undo that square root sign, so we both square 4 minus b equal to 3b minus 8 square. So 16, 4 minus b, that's be 9b square minus 48b plus 64. So that'll be, so we expand the brackets, obviously, so 64 again equal to minus 16b equal to 9b squared minus 4ab plus 64. Sorry, 64. All right, so now you can see, just clean up a little bit area there, error. Okay, so this is a 64. So we got 264 cancelled out. So let's leave it out to 9b squared minus this move to the other side become plus 9b squared be 32b equal to 0. So we take b out. So 9b minus 32 equal to 0. So b equal to 0, which is not applicable. B can't be 0 because the height cannot be nil length. So therefore, our second b, 9b minus 3 to 32 equal to 0. So the answer is B equal to 32 divided by 9. So that's the B is 32 divided by 9. And so that this area, so the area is the maximum. Okay, so maximum area, we can substitute into the original, the area formula. We know area formula is, so the maximum area will be B minus, yeah. So B times by 4 minus B plus, let's continue, have a look at the formula, plus 2B. So if we substitute into the equations, it'll be 32 divided by 9 and times by 4 minus 32 divided by 9 plus 2 times by 32 divided by 9. So total answer, I'm sure you guys should be able to work it out. All right, thank you for watching. So this is the another question in relation to the maximum area. So, but again, the critical point is establish the relationship between the area and the variable you need to decide. So in this case, it's our height of the trapezium. So let's highlight that. So this is the critical point. So when you decided that, you need to go through this formula by using the intersection point. Thank you for watching. See you next time. Bye.